Hello together. This video explains you the diagnostic possibilities in the API Profinet system and TIA portal. What you're seeing here is the running API system. Everything is green, means we have no error. And if we want now to provoke an error, for example, an undervoltage error, then we have to do as first step a parameter change. If we go here offline, and in the device view, then you see here my VDOG, my MPAL, and so on. And per factory setting, undervoltage error will be not transferred to the PLC. You see here, diagnosis suppressed in case of switch off. That I'm getting an undervoltage error in the PLC, I have first of all to activate the monitoring. Now I'm making a download just at this device. And now if I provoke an undervoltage, then my VTUG will send this undervoltage message also to the PLC. At MPAL, you see I still don't send it. And this is the default setting at all API modules with outputs. Going again online, I provoke now an undervoltage message. And you see here directly in TIA portal that my VTUG here has a problem. We have with the API system several possibilities to analyze or to get the diagnostic message. The first possibility is we have a closer look on the LED behavior of the API system. In case of undervoltage, you see here that the related modules where the diagnostic is suppressed are flashing green. The modules where we not suppressed the diagnostic message, where we transmit it to the PLC, are red, flashing here. This is the first possibility to check diagnostic information by the API system, the LED behavior. The second possibility is open the web server. If we have the IP address of the API Profinet master, we can open the web server via a browser, and then we are seeing here again the information concerning the undervoltage as error, or if you suppress it as information in the web server. The web server itself is showing us the 4-byte diagnostic message here directly. We have here 1 byte for the major category, this is 1 byte for the minor category, and this here is the error number. In the system manual, you find details exactly to these categories and also to the error number. That is the second possibility. Check the web server. The third possibility is going directly here in TIA portal. We see here that we have an error. Double click on the error, and then we see first of all the diagnostic status. And here in the diagnostic status, we're getting the information under voltage in the load supply. We also can go directly to the PLC. Here at Online Diagnostic, I have also the diagnostic status of the PLC. The PLC is telling me module exists, but we have somewhere a fault. In the diagnostic buffer, it is a history buffer in the PLC. We are getting always the latest error and previous error listed. The latest error is here. You see again, it is the undervoltage in the load supply. If I now solve the problem, then I'm getting in the diagnostic buffer also the information here, undervoltage in the load supply, but it is solved. And here it was coming in. That means in the diagnostic buffer, I get the whole history of errors of my system. I can additionally, for support cases, save the whole diagnostic buffer as a file here directly on my desktop and send it, for example, to the hotline for a further analysis. To sum up, we have at the moment three easily possibilities to get information. First, the let behavior of the API system. Secondly, the web server with the 4-byte message. Third, directly in TIA portal in the device view if there is the error, or in the diagnostic buffer of the PLC. If we want to have the diagnostic information as programming code available, then we have to do something. First of all, we're going here to the programming blocks, and you see here at the moment there is nothing available in my program. What we make here just the main. We add here a new block for diagnostic. This is here the OB82. This is the block event triggered if a diagnostic error interrupt is coming from a Profinet device, etc. And this is now here the structure. The main OB will be executed always cyclically. It contains my application program. The diagnostic interrupt will be executed event triggered if an error is appearing. Per default, inside the network of the diagnostic interrupt is nothing programmed. To use the diagnostic interrupt correctly, I need a function block. Here you see the instructions on the right side. If you go to distributed I/O, you see here the RALRM. This is the function block which receives the information from a device who has an error in the field. If I'm taking this function block, then it is appearing here in my system, in the network 1 of the OB82. To find out how this function block is working, the recommendation is go to the online help, and then you are seeing here all the information about the function block. In the description, I see here the mode. And you see here in the mode 0, for example, I am getting the information about the component and the parameter ID of the component who has a problem in the field. This parameter ID is the hardware identifier. With the mode 2, I am getting, if I'm knowing the hardware identifier, here called FID, the information about the error. Means I need the mode 0 to find out which components have a problem, and the mode 2 to find out secondly what is the problem. The T-info and add-info are structures. The details are here mentioned in the system. And now the goal is to create the input variables for this block. I can do this very easily if I'm adding a new block, data block called Diagnostic, and defining manually with the help of the information in TIA portal the structure of T-info, A-info, and the hardware identifier. I have done this already in a previous project. That's the reason why I am now doing following. You see here the internal sources. If I'm now add here a new external file, which I have created in the previous project, in my case, data types of this function block. And if I'm making here right mouse, generate blocks from the source. Then you recognize here in the PLC data type the T information and add information which I have created in the previous project. And these are the exact data types based on the information from the online help. I can now copy both data types directly to my diagnostic DB. And the last thing what I have to do is I need the hardware identifier, hardware int, which is a data type of hardware any. So with this information, I'm going now to my R alarm. The first step was we need the mode 0. We have here now to define the T-info. Therefore, I'm clicking inside the field, taking here the diagnostic, go here T-information, none, finished. I need the A-info, the same procedure, diagnostic, A-info, none, enter, finished. And as a result, in the mode 0, I'm getting the hardware identifier, means here the ID, right mouse, diagnostic, hardware identifier. The second step was I have to execute the mode 2. I am just marking the block, Control C and Control V to the network 2. Here I'm saying it is the mode 2. The ID I don't need because I'm knowing it from network 1, and I have to place it now here as input. Finished. And now I have here the structure for the event triggered OB82, which is doing the first step, reading out which device has a problem and gives me as output the hardware identifier. And in the second step, I'm finding out what this device has a problem in detail. Now I am compiling everything, no errors, making here a download to my system, making completely a reinitialization, and I'm going online. You see here, if I'm clicking here on monitoring on, the blocks are now monitored, and I can now here provoke again the undervoltage error. And you recognize now, here I am receiving the hardware identifier of my component or Profinet device who has a problem, 263. Going back here to the device configuration, directly to the API system, marking this BTUG. Oh, going here to properties, system constant, then I'm seeing the 263 belongs to the VTUG. Hardware identifier 263, which is belonging directly to my VTUG terminal. You see here too, if I'm going here to this block here, I have another hardware identifier. That's the reason why it is a must to get here first the hardware identifier of the component which has a problem. Otherwise, this second block here with the hardware identifier will not provide the right information. Going here to the diagnostic DB and making here monitoring, I'm seeing here now in the add info the error number directly here. Error number 0105. Channel number 07D1. 7D1 is meaning 7D1 is 2001. Why do I mention this? Because if you are going to the Profinet manual of the API master, then you are getting here following information concerning the diagnostic. We can at Profinet just send the lower 60 bits because something else is not possible. Means we are not able to send the whole 4 bytes via Profinet to the upper system. The 60 bits include the error number. And the channel error type, in this case it is 2001, includes the error numbers which are in this range. If the channel error type is changing to 2002, we have following range. The 0105 means under voltage. We can check this easily if we have a closer look on the system manual. There we are seeing here the under voltage message 0105. If we provoke, for example, another code here, short circuit, then the message in our programming code will also change. Going here back, first of all, I'm solving the under voltage message. No errors anymore. Now I'm provoking a short circuit. And you recognize that the error code has changed to 010B. That is showing me that my whole programming code is working, and that was now a simple introduction how you can use the OB82 with the corresponding function blocks to get the information from the API Profinet master inside your PLC code. Thanks for your attention and have a nice day.